This is the second of a series of me doing a linear epsilon delta proof. There's one already on your videos. This is the second. And this is about proving, so we can look at a graph and see a real graph with the real numbers that has to do with epsilon and delta and a linear equation. So suppose, and this is going off the deep end again, look at number one, and now here is number two. We're talking about a limit of a function, it doesn't matter what function we use, as x approaches 3, and we get the number 7. And then I tell you to prove this if we're not going to use epsilon greater than 0. Epsilon we said was tiny, so we'll use epsilon equal 0.01. Now, when I did number one, I talked about that the road to Austin and to Houston, or Houston to Austin, we could go either way in a proof. From the if to the then, or the then to the if. So you have to look at number one before you look at number two. Well, not only am I going in what is doing the proof backwards, I'm also using a certain dimension to epsilon. So with this, and if you remember your structure, if for each epsilon greater than 0, this epsilon is going to be 0.01. There is a delta. Now we're making epsilon equal 0.01. There is a delta. I don't know what it is, but it's greater than 0, such that if we're in a deleted neighborhood of x minus c less than delta, well, our c in this case is going to be 3, then f of x minus L will be less than epsilon. So this will be 0.01. Our f of x is going to be 2x plus 1, and our L is going to be 7. Okay, let's go. We're starting from the end. We're going to start from f of x minus L is less than epsilon. So that means we're going to start from 2x plus 1 minus L, which is 7, is less than 0.01. What do you get? You get 2x, I'm drawing, is less than 0.01. You factor out the 2 like I did before. I'm going to start taking shortcuts because I know you did number one. You divide by 2. And if in our if statement we get x minus c is less than delta, that means that for epsilon equaling 0.01, delta is 0.01 over 2, half of it. So that means it's 0.005. That means, and I know that I talked about guns and I talked about a quarterback throwing a ball, etc., that the domain's error has to be half of the range's error. Interesting. So change your pens. And let's go the other way. So we say, suppose epsilon is equaling, oh, not epsilon, delta. I have a thick pen. I'm going to have to get a fine point. That delta is equaling 0.01 over 2. Here we go. I gotta adjust this pen. This is okay, but let's see the width. Now, think about working backwards. We have 0 less than x minus 3, because that's c, less than delta. We are starting now with the if statement, and we're going to the then statement. Now we're going this way. The first time we went basically backwards. Here was the then, we went to the if, now we're going to the if, then we're going to the then. Multiply by 2. Get your 2x minus 6. Look, I'm retracing those steps. Look at how I'm retracing my steps here. There's all kind of ways of writing the number 6. I'm going to drop the 0. I'm going to rewrite it as plus 1 minus 7. And I'm going to say, therefore, I'm coming up and finishing it up here. Therefore, if epsilon is equaling to 0.01 in this problem, then delta is equal to 0.01 over 2. Here, right before I say the therefore, I'm going to say, this is of the form the absolute value of f of x. This is not an easy game. Minus L is less than epsilon. Now look at it. You worked backwards, then you worked forwards with a supposition. That QES means supposition. When you get to your then, if, then, you make a statement. This is of the form of the then of the original definition. Therefore, if epsilon equals 0.01, which was given, then delta is 0.01 over 2. Okay. Now, what you have to work now, you go to, and you have to find it. It is called limit supplements. Yes, it's out there. You find limit supplements, and you are going to be working the limit supplements, and I have the problem starred. I'll bring it up, and that's the first thing you're going to do related to problems 1 and 2. They all are linear. Thank you. Good night.